In this problem, we're given a graph and we want to write a possible equation for this graph. And I'm assuming that you're doing this problem at a point in a class where you've learned transformations, how to shift a graph up, down, left, and right, and no more than those 4 transformations. I'd like to start my exploration by going to a website called Desmos.com. Here's how you spell Desmos if you're interested in going to this website. And I'm going to start by typing in an equation that I know produces something like the V-shaped curve that we saw a second ago. The toolkit function that produces such a graph would be f of x equals absolute value of x. You would get the absolute value symbols by clicking the show keypad icon here. Clicking the absolute value symbols, now I'm going to hide the keypad by clicking the X here. And then I'm going to type the letter X. That gives me an absolute value function. Notice bottoms out at the point 0, 0, and that would be the lowest point on that graph. However, if you notice, the graph for which we're trying to produce has a minimum point or lowest point of -1, -3, which means we need to take the point 0, 0, which is the lowest point on y equals the absolute value of x, and we need to change the equation y equals absolute value of x so the lowest point is no longer 0, 0, but is now -1, -3. So to move this point to this point, you would have to move to the left 1, and then after doing that, you would have to move down 3. So to explore how to move a graph left and down, let's go back to Desmos. If you take the output of the function, that's f of x, or you could think of that as the absolute value of x, and you were to write that down and simply add a number to it, say 2 for example, you can see that that moved the graph up 2. Had we subtracted 2 instead of adding 2, the graph would move down instead. So it looks like to get the graph to move down 2, the equation would look like this. Now if you remember, our job was actually to move down 3, so that would be accomplished by subtracting 3 on the output. Now I need to figure out how to accomplish the other goal, which was to move left 1. So the other thing that you may have learned at this point in the class, in addition to adding or subtracting a number to the output of a function, you can add or subtract a number to its input. So the input to the original function is x. If I was to add a number to the input, say add 1, notice that it moved the point left 1, and then the -3 moved it down 3. In fact, this is the exact goal for our particular problem. But just so you know, had I subtracted 1 on the input, it would have moved the graph to the right 1, and then the -3 moved it down 3. Let me change it back to the one we wanted. So the answer to our question is absolute value of the quantity x plus 1, and then subtract 3. Even though I've given you the solution to this particular problem, we could look at this problem in a little more detail by using function notation. I started by identifying that the toolkit function for the original graph was the absolute value function. So I started with f of x equals the absolute value of x. One way to denote that you can add or subtract a number to the input of the function is to put a letter here. For our example, we added 1, but in general you could add or subtract any number. So I'm going to choose to put the letter C here to represent a number that we were going to add or subtract. If C was positive 1, then we would be adding. If C was a -1, replacing C with -1 would actually change this to x plus -1 or x subtract 1. So notice that if C is positive, you can think of it as we're adding. If C is negative, you can think of it as we are subtracting. So you need not use a plus or minus symbol in here to represent both cases. You will get subtraction by simply thinking of C being a negative value. And then to represent that you can add or subtract a number on the output of the function, think of this as the notation for the output. And you could add or subtract a number. In our case, it was subtracting 3, but you could generalize this to adding any number. We'll call it D. And if the number for D was positive, you could think of it as you were adding it, and that would shift the graph up. And if D was negative, you could think of it as we're adding a negative or we are subtracting a number, and that would move the graph down. So for our problem, we let C be 1, and if you replaced C with 1, you'd get a plus 1 here. And if you replaced D with -3, and the reason I chose it to be negative is because the 3 over here is being subtracted. Here's my original function f of x. What we did was f of the quantity x plus 1, replacing c with a 1. And then after that, we added the constant d, and our d is negative 3. So adding a negative 3 can be thought of as subtracting 3. Now, actually evaluating that notation, I will move my work up here to give myself some room. Here's f of x equals the absolute value of x. Suppose I wanted to do the first part of this expression here, f of x plus 1. F of x plus 1 means to take x and replace it with x plus 1. And if you do it for this input, you would do it for this input as well. So you can think of this notation, f of x plus 1, is meaning take the input of your original function and replace it with x plus 1. If you did so, you got the first part of the equation that we found. But now, as a second step, we must subtract 3 on this. So if I literally made a copy of the left-hand side and literally made a copy of the right-hand side, you could think of it as we currently have f of the quantity x plus 1 sitting here, but my goal was to get f of the quantity x plus 1 and then minus 3. So if I want a minus 3 here, if you do it to the left-hand side, you'd have to do it to the right-hand side. So you can think of this as if c is 1 and d came out to be minus 3. Performing exactly what that notation means to do with the original equation gives me this equation. And graphing that equation does indeed give me the graph that was originally posed in the question.